Good day everyone. We will be tackling today about reliability-centered maintenance. So, what is reliability-centered maintenance? When you say reliability, the quality of being trustworthy or of performing consistently well, and maintenance, the process of maintaining or preserving someone or something, or the state of being maintained. So, what is reliability-centered maintenance? Truly mean is that uh, it is the state of being reliable. Yeah, that's what it is. And what is reliability centered maintenance? So, RCM is the process of determining the most effective maintenance approach. The RCM philosophy employs preventive maintenance or PM, predictive maintenance PDM, real time monitoring RTM, run to failure, or also called as reactive maintenance, and proactive maintenance. So last, these techniques in an integrated manner to increase the probability that a machine or component will function in the required manner over its design life cycle with a minimum of maintenance. So the goal of the philosophy is to provide the stated function of the facility with the required reliability and availability at the lowest cost. RCM requires that maintenance decisions be based on maintenance requirements supported by sound technical and economic justification. So, ang ginamin lang niyan is nag-perform ang RCM, hindi lang basta-basta. So, dapat uh, those requirements or maintenance requirements are supported by sound and technical economic justification. So, a brief history of RCM. So, reliability under maintenance mainly originated in the airline industry in the 1960s. So, by the late 1950s, the cost of maintenance activities in this industry had become high enough to warrant a special investigation into the effectiveness of those activities. So accordingly, in 1960, a task force was formed consisting of representatives of both the airline and the FAA to investigate the capabilities of preventive maintenance. So the establishment of this task force subsequently led to the development of a series of guidelines for airlines and aircraft manufacturers to use when establishing maintenance schedules for their aircraft. So this led to the 747 Maintenance Steering Group with their document MSG1, and their handbook is Maintenance Evaluation and Program Development from the Air Transport Association in the 1968. So MSG1 was used to develop the maintenance program for the Boeing 747 aircraft, the first maintenance program to apply concepts. MSG2, the next revision, was used to develop the maintenance programs for the Lockheed L-1011 and the Douglas DC-10. So this was the two airplanes who first used the RCM concepts for their maintenance. So the success of this program is demonstrated by comparing maintenance requirements of a DC-8 aircraft maintained using standard maintenance techniques and the DC-10 aircraft maintained using the MSG2 guidelines.
Recently, she's lost that crown to the bigger Airbus A380.
So that video I got it from YouTube. So in the 1947, the U.S. Department of Defense commissioned United Airlines to write a report on the process used in the civil aviation industry for the development of maintenance programs for aircraft. This report was written by Stan Nolan and Howard Heap and published in 1978. It was entitled Reliability-Centered Maintenance and has become the report upon which subsequent reliability-centered maintenance approaches have been based. So what Mr. Nolan and he found was many types of failures could not be prevented no matter how intensive the maintenance activities. Additionally, It was discovered that for many items the probability of failure did not increase with age. Consequently, a maintenance program based on age will have little, if any, effect on the failure rate. RCM, or reliability is under maintenance in the facility and utility area. So the primary RCM principles are RCM is a function oriented. So when you say function oriented, it seeks to preserve system or equipment function, not just operability for operability's sake, redundancy of function through multiple equipment, improves functional reliability, but increases life cost in terms of procurement and operating cost. So RCM is also system focused. So it is more concerned with maintaining system function more than individual component function. Next is RCM is a reliability centered is reliability centered. It treats failures as statistics in an actuarial manner. The relationship between operating age and the failures experience is important. RCM is not overly concerned with simple failure rate. It seeks to know the conditional probability of failure at specific ages. So the probability that failure will occur in given operating age bracket. RCM acknowledges design limitations, so its objective is to maintain the inherent reliability of the equipment design, recognizing that changes in inherent reliability are the province of design rather than the maintenance. So maintenance can at best only achieve and maintain the level of reliability for equipment which is provided for by design. So RCM is driven by safety and economics. Safety must be ensured at any cost. Thereafter, a cost effectiveness becomes the criterion. RCM defines failure as any unsatisfactory condition. Therefore, failure may be either loss of function or a loss of acceptable quality. RCM uses a logic tree to screen maintenance tasks. This provides a consistent approach to the maintenance of all kinds of equipment. RCM task must be applicable. The task must address the failure mode and consider the failure mode characteristics. RCM task must be effective. The task must reduce the probability of failure and be cost effective. Acknowledges three types of tasks. So, time directed or PM, as scheduled when appropriate, condition directed PDM, and real time monitoring. Performed when conditions indicate they are needed. Failure finding, one of the several aspects of proactive maintenance. Equipment is run to failure. This is acceptable for some situations and some types of equipment. RCM is a living system. It gathers data from the results achieved and feeds this data back to improve design and future maintenance. This feedback is an important part of the proactive maintenance element of the RCM program. Failure. A piece of equipment can be operating, for example, an HVAC unit in a clean room, for example, but if its output is less than required, it would be considered failed. On the other hand, a proactive relay in a power system can have failed, but if it has not taken the circuit offline, the circuit is still energized. The function of the system is unchanged. Essentially, defining failure depends on the function of an item or system and the operating context in which the system is used. Functional failure. A complete loss of function is a functional failure. If the system's output is less than specified, a functional failure has been occurred, even if the system is still operating. A functional failure is essentially the inability of a system to meet its specified performance standard. Consequences of failure. The consequences of failure determine the priority of maintenance activities or design improvement required to prevent occurrence. If the failure of an item results in a little or no consequence, minimal maintenance activities are generally required. If, however, failure of an item results in a large economic hardship, personal injury, or environmental damage, maximum maintenance activities or a redesign may be called for. Maintenance actions in an RCM program. Spo- uh, Specific RCM objectives as stated by Nolan and Heap are to ensure the realization of the inherent safety and reliability levels of the equipment, to restore equipment to these inherent levels when deterioration occurs, to obtain the information necessary for design improvement of those items whose inherent reliability proves to be inadequate, to accomplish these goals at a minimum total cost, including maintenance costs, support costs, and economic consequences of operational failures. The RCM goals are to identify the most effective and applicable maintenance techniques to minimize the risk and impact of failure in facility and utility equipment and systems. This allows systems and equipment functionality to be maintained in most economical manner. To this end, there are four outcomes from an RCM analysis. Perform no maintenance. This is referred to as reactive maintenance, repair, fix on fail, or run to fail. This type of maintenance assumes that failure is equally likely to occur in any part, and that a failure is not detrimental to the operation. When we say detrimental, meaning tending to cause harm. When this is the sole type of maintenance practiced, high failure rates, large parts inventories, and excessive amounts of overtime become common. A purely RTF maintenance program ignores many of the opportunities to influence equipment survivability. Number 2. Perform preventive maintenance. PM consists of regularly scheduled inspections, adjustments, cleaning, lubrication, and replacement of components and equipment. PM is also referred to as time-driven or interval-based maintenance. It is performed without regard to equipment conditions. PM schedules inspection and maintenance at predefined levels in an attempt to reduce equipment failures. However, as Nolan and Heath discovered, PM program can result in a significant increase in inspections and cost without any increase in reliability. Number 3. Perform condition-based maintenance or CBM. CBM consists of predictive maintenance or PDM and real-time monitoring. PDM primarily uses non-intrusive testing techniques to measure and trend equipment performance. Real-time monitoring uses current performance data to assess machinery conditions. CBM replaces arbitrarily timed maintenance tasks with maintenance that is scheduled only when warranted by equipment condition. Continuing analysis of equipment condition data allows for planning and scheduling maintenance activities or repairs prior to functional or catastrophic failure. Number 4 is redesign. An RCM program will include all four. No. Redesign, when failure of a system or piece of equipment is an unacceptable risk and none of the above tasks can help mitigate the failure of a redesign of the equipment or system is in order. In most cases, adding redundancy eliminates the risk and adds very little to overall maintenance cost. An RCM program will include all four of the above analysis outcomes, as one is more important than another. Impact of an RCM on a facility's life cycle. So even though maintenance is a relatively small portion of the overall life cycle cost, typically 3% to 5% of a facility's operating cost, RCM is still capable of introducing significant savings during the O&M phase of the facility's life. Savings of about 30 to 50% in the annual maintenance budget are often obtained through the introduction of balanced RCM program. For the conclusion, reliability-centered maintenance is the process of determining the most effective maintenance approach. As the airline industry showed 40 years ago, RCM cannot only improve the reliability of a system, it can significantly reduce the required maintenance. In today's competitive world economy, that translates into money saved, both from reduced failures and reduced work, and a properly implemented RCM program will continue saving money year after year. To maintain competitive, most companies can no longer afford to maintain on the sidelines doing things like they're always done. Let RCM move your maintenance into the 21st century.